Hi there! I see you're interested in programming. In the last video of this programming series, we talked about logic and string operations. In this lesson, we'll introduce you to a few basic programming structures like the if statement. There are many ways to program. The end goal is to solve a problem. But there are multiple ways to tackle it. That's where programming paradigms come into play, as a way to classify programming languages. There are many paradigms, but to simplify things, we'll divide them into two major categories: imperative and declarative. In our lessons, we'll teach you about the structured paradigm, which falls under the imperative category and is the most commonly used. In the structured paradigm, we have basic structures that we will use to compose our algorithm. These are sequential, conditional, iterative. In this video, we'll learn about the sequential and conditional structures. The sequential structure is the simplest. It's a succession of instructions that should be executed in order from top to bottom. Instructions like assigning a variable, showing a text, etc. Let's call on John and Molly to give you an example. John and Molly's parents gave each of them their allowance. Let's write that down in pseudocode, like in our previous lessons. We'll define two variables, John and Molly, both as ints. John's mom, Laura, gave him $5, and Molly's dad, Rick, gave her $4. This is a visualization of the structure of our algorithm. We'll show these for each example moving forward, so that you can get an idea of how our algorithm is executed. The rest of the structures we'll learn can also be added to the sequence of instructions. This way, we'll slowly start to construct our algorithm. At some point in our algorithm, we're going to want to make choices or decisions based on our information. That's where the conditional sequence makes its appearance. There are multiple ways to express a conditional sequence. These are: if we have one choice, we use the sequence if, then. If we have two choices, we use the sequence if, then else. If we have multiple specific options, we use the sequence switch. When you need to make a choice whether you should do something or not, you should use the if statement. The if statement has a condition and a series of instructions to follow. The condition is a boolean, and you can use logical operations inside of it. If the condition is true, the series of instructions are executed. If the condition ends up being false, none of the instructions are executed, and it simply skips them over. Here's an example we can use to try out the if statement. Let's see what Molly's up to. Hey there, Molly. Molly says that if she gets a good grade on her math exam, her dad will double her allowance. Molly's regular allowance is $4. She gets graded on a scale from 1 to 10. Her dad, Rick, wants Molly to get at least an 8 out of 10. How about we turn that into code? We need to hold on to Molly's allowance and her grade, so let's define two variables, Molly and Molly's grade. We know that her allowance is 4, but what we didn't know is that Molly got a 9 out of 10 on her exam. Congratulations, Molly! Now it's time we use our if statement. We know that Rick wants Molly to get at least an 8 out of 10. That would be the same as saying that Molly's grade has to be equal or greater than 8. So our condition will be Molly's grade greater or equals to 8. If that ends up being true, Molly's allowance will be doubled. Let's add that instruction inside our if statement. Finally, we get to see if Rick doubles Molly's allowance. Molly's allowance is 8. In this scenario, the order of instructions that will be executed is A, B, followed by C, D, and then E. When we get to C, since Molly's grade is 9 and 9 is greater or equal to 8, we'll enter the if statement and perform the instruction D. This means that Molly's allowance is doubled. Yay! But what if Molly got a 7 on her exam? How would this change things? In that scenario, the order of the instructions is A, followed by B, C, and then E. Since 7 is not greater or equal to 8, we end up skipping instruction D and going straight ahead to E. This means that when we show Molly's allowance, the result is 4. Molly would probably be sad right now if that happened. The next conditional sequence we're going to take a look at is the if-else statement. This is used when you need to choose or decide between which of two possible sets of instructions to execute. It has a condition and two series of instructions to follow. If the condition is true, only the first set of instructions are executed. If the condition is false, only the second set is executed. In this situation, compared to the normal if statement, you're forced to execute one and only one of the two blocks of instructions. Molly's happy. She got a good grade and doubled her allowance. Now she wants to go to the movies. A ticket to the movies costs $5. Will she have enough? Let's write this down. Let's start by declaring a constant for the cost of the ticket. We'll call this ticket cost. It'll be an int, and we'll assign it a value of 5. We're also going to need a variable to hold Molly's allowance, and another one to hold our outcome. How about Molly and outcome? Molly has $8 in her pocket. Our condition has to compare the amount of money Molly has and the cost of the ticket. This means that Molly must be equal or greater to than the ticket cost. If it's true, then the outcome is that Molly gets to go to the movies. If it's false, she won't have enough to buy the ticket and have to stay at home. After all that, we take a look and see what our outcome was. In this scenario, the order of the instructions that will be executed is A, followed by B, C, and then E. When we get to B, since Molly is 8 and ticket cost is 5, 8 is greater or equal to 5. That means the condition is true. We'll enter the first block of code and perform the instruction C. Our instruction E will reveal that Molly can purchase a ticket. Molly gets to go to the movies. She's really excited. But what if Molly didn't have enough money? What if she didn't have her allowance doubled in the last example? In that scenario, the order of the instructions is A, followed by B, D, and then E. Molly's normal allowance is 4, and since 4 is not greater or equal to 5, the condition is false. So, instead of entering the first block of code, we enter the second one and perform the instruction D. Executing our instruction E reveals that Molly is short on money and can't afford a ticket. Molly would probably try harder on her next exam. She loves going to the movies. The last conditional we've got for you is called the switch statement, also known as the case statement. This statement is great when you have a lot of possible outcomes and only need to execute one of them. It has a control variable, a set of constant values to compare to the control variable, each with their own set of instructions, and a default section in case it doesn't match with any of the other values. Just like the if-else statement, you must execute only one of them. This means that all conditions must be mutually exclusive. For this to happen, you can't have multiple values be equal to the control variable at the same time. We've been talking about Molly so much, I lost sight of John. Where are you, John? Hey! John also loves going to the movies, but he's got a problem. He's got enough money from his allowance, but his mom Laura might not get back from work before the movie starts to give him a ride. Good thing she works nearby. The movie starts at 5, and Laura's shift usually ends at 4, 5, or 6 o'clock. Today, Laura ends her shift early and arrives home at 4. Will Laura get home on time for the movie? What would this look like in code? We need a variable that tells us when Laura gets back from work and another to hold our outcome. Let's call them mom time and outcome as an int and string respectively. Laura ends her shift early and comes home at 4, so mom time will be 4. We know that Laura can come home at any time, but she usually arrives at 4, 5, or 6 o'clock. The great thing about programming is that you get to choose how to solve the problem and give the solution. And for this problem, we want to have a different text for each possible hour. To have different texts for different hours, we can use a switch statement. We'll have to compare mom time with 4, 5, and 6, and also make sure to include other possible times, like 3 or 7. If Laura comes home at 4 o'clock, then John gets to go to the movies. If she arrives at 5, they won't make it to the cinema in time. And if it's 6, then John definitely won't get to see the movie. and if she arrives at any other time than that, I guess we'll have to check it out for ourselves. We ended off by showing our outcome. In this scenario, the order of instructions that will be executed is A, followed by B, then F. After A, we have multiple conditions to verify. Since mom time is 4, then the switch statement will execute the instruction B. Instruction F tells us that Laura arrives early, and John can't wait to see the movie he's been looking forward to. Let's try this code supposing that Laura got home at 8 o'clock. In that scenario, the order of the instructions is A, followed by E, and then F. Since there are no conditions that would be true with mom time equaling 8, the switch statement chooses the default section and executes the instruction E. Our instruction F tells us that she came home before 4 or after 6. Unfortunately, we lumped up all the other times under the default section, so we don't know if Laura arrives really early or too late. Don't worry though, we can fix this. How about we play around with this example and add an if statement to solve our problem? We'll add an if-else statement to the default section, where we'll check if mom time is lesser than 4. If that's true, that means Laura came home really early. If it's false, this means that Laura came home really late. Now, let's try running this example again with mom time equaling 8. The series of instructions is A, followed by E, G, and finally H. After entering the default section, we evaluate if mom time is lesser than 4. Since this isn't true, we enter the second block of code and execute instruction G. Finally, instruction H tells us mom probably had a rough day. I hope we can go to the movies tomorrow. Remember when we said that you get to choose how to solve the problem? In the example we just saw, we could have had a value for each hour from 1 to 12. Although it would work just as well as our example, it would be a lot longer, with a lot of instructions being repeated. It doesn't look too good either. We could also use only if statements and get the same result. This is done by nesting one inside of another, like so. Just because you can use only one kind of statement doesn't mean you should. They each have their pros and cons. Combining different statements gives you more flexibility, and you can make your algorithm look a lot cleaner and easier to understand. Programming isn't just about getting the job done. It's about making sure that both you and anyone else that has to work with your code understands what you did and why you did it. Just like we did in this example, we'll probably need to add new things to our existing code. If you don't remember or understand how your code works, you spend a lot of extra time and effort analyzing instead of actually designing and implementing. A good foundation makes for a smooth experience. Okay, let's recap. We learned about the if statement that has a condition and a series of instructions to follow if that condition is true. We learned about an extension to the if statement, the if-else statement, which adds another set of instructions to follow if the condition is false. And finally, the switch statement, which chooses a set of instructions to execute based on what condition matches the control variable. Things to note. Most of the time, you'll be using the if and if-else statements due to how necessary it is to make decisions based on conditions. Like for example, is the light turned on? You'll need a light turned on variable. Are there more than 10 people at the party? Is people greater than 10? Did you finish your homework and clean your room so you can go outside to play? Finished homework and room cleaned. Using the switch statement tends to be harder because you can't use conditions. Rather, it serves as a way to match one variable with a lot of pre-existing values. When coding in most languages, switch statements tend to be more efficient than using a lot of nested if statements. This means that they're faster when trying to match a variable with a large amount of values. In the end, even if one is faster than the other, don't lose sleep over it. It's better to make code that is easier to read than it is to make code that's more efficient. Most of the time. It depends really. We've arrived at the end of our lesson. The next 3 videos in the series will be interactive activities containing everything we've learned from lesson 1 to lesson 4. Putting your skills to practice is the best way to learn, so make sure you're subscribed and ring the bell notification so you don't miss them. As usual, if you have any questions or suggestions, leave them in the comment section below. And if you enjoyed this lesson, please give the video a like. We hope these lessons will allow you to learn programming from the bottom up. Don't forget, although programming is hard, why don't we make it easy?